Today we're going to talk about linear equations with three variables. So for example, 4x plus 2y plus 3z equals 1. So we're used to seeing things with just x and y. Things with just x and y are a line on a graph. But when you add in a z, it actually turns it into a plane. So it makes it have three dimensions, x, y, and z. It's in three dimensions. So what this means is if we have a lot of these together, like 4x plus 2y plus 3z, and let me delete this. So if we have this one and maybe some other ones as well, like 2x minus 3y plus 5z equals negative 14, and another one, 6x minus y plus 4z is negative 1. If we have three of these are three planes, and when we want to find the solution, there are a few different things that can happen, because we want to find out what x is, we want to find out what y is, and what z is. So we get an ordered triple. When we're used to seeing an ordered pair, x, y, we're actually going to get an ordered triple as a solution. And it can look like this. There could be a situation where they intersect in a single point like this. These are the three different equations. They intersect right here in the middle. There's a situation where they have infinitely many solutions because it'll go up and down forever. All of those are on the same plane. This is from page 178 as well. And there's a chance where they have no solution, like there's no single place where those three will cross. Like two of them will cross, but there's no place where all three of them will cross. So now is for the fun part, is actually trying to solve this and find out what x, y, and z are. It's a very lengthy and difficult process, so you really have to be careful. You really have to take your time. So what you do first is take two of the equations, let's say these two, and we're going to create one equation with two variables. So we're going to get rid of one of those three variables. Then we're going to need to take another two, okay, maybe these two this time. We'll create another equation with the same two variables. And we're going to do this in the same way as we did 3.1. We're going to multiply across to eliminate or substitute. So let's go ahead and write this one down. So we get 4x plus 2y plus 3 equals 1, 6x minus y plus 4z equals negative 1. So we'll write that here. Now, I'm going to add these together, and I have to choose which one we want to get rid of. I think it's going to be the easiest to get rid of y, since this one's positive 2, this one's minus y. So I'm going to multiply this whole thing by 2 to get my new equation, which is 12x minus 2y plus 8z equals negative 2. Okay. Now we can add those together to get 16x, y's cancel out, plus 11z equals negative 1. Okay. So I did this first part. I created one equation with two variables. Now I'm going to create another equation with the same two variables. So let's try that. We did 2x minus 3y plus 5z equals negative 14. And 6x minus y plus 4z equals negative 1. And we have to decide what we want to do, like how we're going to change this. I think the way we're going to do this is maybe multiply this bottom equation by a negative 3 so we can get rid of y again. Remember, we have to get rid of the same variable twice. We got rid of y here, we have to get rid of y here as well. So what's going to happen? Negative 3 times 6 is negative 18x plus 3y minus 12z equals positive 3. And now we're going to add those together to get our new equation, which is negative 16x, y's cancel, minus 7z equals negative 11. Okay, I need to make room for some more stuff here, so I'm going to go ahead and erase a little bit, but you should never erase this, of course. I'm going to leave those original equations at the top, even though we're just working with these two right now. So we go ahead and write those down. 16x plus 11z equals negative 1. We have negative 16x minus 7z is negative 11. And we're going to decide what we want to do with those. So remember, now we're just doing exactly what we did in 3.1. We're just going to eliminate one of those things. So we can eliminate the x right away. We don't even have to change it this time. Those just cancel. We'll just add them together. And we get 4z equals negative 12. Z equals negative 3. Alright, so we finally got something. We know z is equal to negative 3. So in that order, triple x, y, z, we at least know one of the answers is negative 3. Now what we're going to do is take this and put it into this equation, because this is the only one we can use. Well, either one of these. We cannot take it and put it into this, because that one still has two variables we don't know. We have to put it in one of those two with only one. So let's, one of those two with only two variables. So let's plug it into this one. 16x plus 11 times negative 3 equals negative 1. 16x minus 33 equals negative 1. Add 33. 16x equals 32. X equals 2. Now we can take that x and that z and plug them both into one of the first equations at the top, because we can get y in that way. So I'm just going to choose this one. So 6 times 2 is 12 minus y plus 4 times negative 3 is minus 12. Minus 12 equals negative 1. So the 12's cancel. We have negative y equals negative 1. Y equals 1. So answer is 2, 1, negative 3. So that was a situation in which there was exactly one solution, because they those three planes crossed each other at one point. I'm going to show you what happens. Sometimes you're going to get no solution. So for example, x plus y plus z equals 3. So let's say we have these three equations. X plus y plus z equals 3, and these other two. So of course we're going to do the same thing. We're going to try to make two equations. I'm just going to pick two. I'll pick those two, and I'll pick these two. It doesn't matter, once again. We've got to eliminate one of the variables. Let's try the top and the bottom. X plus y plus z equals 3. 3x minus y plus 2z equals 5. So what are we going to do here? We'll just multiply the top one. Well, actually, we don't need to do anything, because the y's will cancel out, the plus y and the minus y. So we'll add those together. We're going to get 4x plus 3z equals 8. Okay. The next one, let's add it together. So the next one we have 4x plus 4y, 7, 3x minus y plus 2z equals 5. We got to find out what we want to do. We're going to try to get rid of that y again, so we need to multiply everything times 4. You get 12x minus 4y plus 8z equals 5. Add those together. 16x plus 12z equals 5. Alright, now we have two equations. We're going to combine those two and hopefully get rid of one more variable. We'll combine this two. I'm just going to write this one underneath. So 16x plus 12z equals 5. To get rid of, let's say we want to get rid of the x or the z. Let's say we want to get rid of the z, so multiply times negative 4. So we're going to get negative 16x minus 12, z equals negative 32. See, now 16 and 16 cancel, negative 16 and 16 cancel, negative 12 and 12 cancel. It leaves us with 0 on this side. Then we say 0 equals negative 27. This is impossible, so whenever this happens, like you know from section 3.1, this is no solution. This cannot occur. So like we said, a no solution is where you end up with something where all the variables are gone and you get something like 0 equals 5 or something ridiculous like that. That's no solution. The opposite is when the other thing happens, when you get a solution that's like 12 equals 12 or 0 equals 0. When this happens, that means that it is a true statement, and this actually is when you have infinite solutions. And I'm not going to walk you through this one because I've showed you 2 examples already, but just know that when that happens, that's an infinite number of solutions.